So I just want to welcome everyone to our Commanded monthly webinar. Commanded is the Center for Minorities and People with Disabilities in IT. Just to give a little more background, so Commanded is the presenter of the Tapia Conference, which is scheduled for September 10th through the 12th in Dallas, Texas. So we'll be in Texas this year. So invite everyone to join us as well in Dallas, where the program will focus on generative AI. So a popular topic. And so today we have the wonderful pleasure of hearing from Jensen Bouzi, who is a tech lead with over 10 years of experience in software engineering. He currently serves as the tech lead at Atlassian Corporation, which is based in Australia. He has previously worked with several companies, including Better Mortgage, MongoDB, and the Wall Street Journal. And so today we have the pleasure to focus on his career journey from Amherst College to tech lead at Atlassian. So I want to welcome Jensen to our monthly webinar. And actually want to start with some details about what you do. And that is, if you could tell us a little bit more about your current position as tech lead, identifying your responsibilities, and also a little bit too about Atlassian. So with that, I'll turn it over to Jensen.
Absolutely. Thank you so much, Valerie, for having me. Thank you, everyone who joined the webinar and interested in hearing my story. I'm really humbled by that. And to answer your question, I'm a tech lead at Atlassian. And what does a tech lead mean? A tech lead can mean different things at different companies. Sometimes a tech lead is kind of like a hybrid of a manager or a manager and an engineer. So you kind of have people management responsibilities and software engineering responsibilities. But at Atlassian, a tech lead is essentially a senior engineer. So I'm a senior front-end engineer. But the tech leads are the ones who lead the projects. And so what does that mean? Specifically at Atlassian, it's you're doing all the research to figure out what is the right solution based off the requirements. You're working with the product manager to solidify the requirements. You might need to work with the designers to make sure, hey, these designs, are they, accessible? Uh, are they feasible? And you're kind of working to solidify those requirements. Then you do all the research to figure out, based off these requirements, the designs, what is the optimal solution for the team? You create a tech spec, which is a essentially detailed technical solution. And then you're probably given your manager probably gives you a few engineers from your team that you're going to delegate work to essentially get the project done. So maybe it's me and another senior engineer, me, a senior engineer, and two junior engineers. I'll
Mhm.
create the tech spec. I'll be interacting with all the leads. I'll go through the whole tech spec with them, make sure we're all on the same page with the solution. We divide and conquer on the tasks. And essentially, I'm responsible for delivering the project. And what does that mean? That means I'm not only doing the tasks that that I own, but I'm also keeping track of what is everyone else doing? Are we going at a good pace? Always having a gut check to see, okay, here's the timeline that we said we're going to do. Are we going to hit that? Are we going to be delayed? If we're going to be delayed, raising that to stakeholders, and also not just being like, hey, we're going to be delayed by 2 weeks, but having a backup plan to make sure that we could get back on track. And so you're always keeping a gut check of the pace of the project and making sure that it delivers on time and making sure that everyone's working cohesively. And you're also, you have to uh, support the fellow engineers with the work that they're doing. And that's just for the project. So that's a big part of what I do, but that's just for project to project.
Mhm.
I might be doing that. I might have one project where I'm doing that at the same time. I might have two projects at the same time that I'm doing that. But also being a tech lead means you are a domain expert for everything that your team owns. So every software engineering team, there's a certain part of the product or the code base that they own. And so they're responsible for, hey, this is our code base. This is what these things mean. This is how you use it. And so for my team, if there's anyone unsure about, where things are, what certain things mean, how to do certain things, I'm one of the first people that they reach out to. And it's not just people on my team, but people throughout the entire department, people from other teams. If they have questions like, hey, you know, um, our team is called the Confluence Cloud Better Together team. So they're like, hey, Better Together, I'm using your component. I want to do this XYZ, but I'm not sure how to integrate into it. How can I do this? And then someone might tag me in, and I'll kind of spar with that person and come up with a whole architecture of how they could use our component. And so I'm still responsible for having a deep knowledge of what we own and making sure that I'm a resource to other people. So that's like a second part of it. And I think the third part of it is mentorship and making sure that I'm maintaining the a high essentially code standard for the team. And so what does that mean? Mentorship is when people put out their code and they want their codes to go to be reviewed. I try to make sure that even if it's not my project, I'm reviewing other people's code on the team, giving them feedback on not just if it's right or wrong, but does it follow best practices? Is the code clean? Is the code scalable? Does the code take into account products that we might build in the future? Right? Is it flexible? Does it have tests? Is it resilient? Is it secure? Is it all those things? And so I'm branching out beyond my projects to make sure that we are maintaining a high code quality. And that's also by me giving reviews to other people, that's also how I mentor people. So if there's a junior engineer putting up code, by them constantly receiving feedback from me, they know, okay, I need to write code in this way. I need to make sure, oh, if I do this, I can't forget about writing the tests because they're constantly getting that feedback from me. So that's another way to mentor. And so overall, that's, what a tech lead is. It's someone who, leads who creates the technical solution for the projects, responsible for delivering the projects and leading teams to deliver the projects, is a domain expert on everything that the team owns, and also is responsible for mentoring other people in the team and making sure that uh, you're pretty much getting the best out of everyone on the team.
Wow, that is fantastic. So, a couple of questions here, and I see one too in the chat that I'll bring forth. And that is, some questions like what's the duration of a project? Is it several months? And how big can a team grow? And then there was a question also from Emichi, and that is, you know, what's included in the tech specs? So I'll stop there.
Yeah, those are great questions. Projects could span, they could be small, maybe a couple of weeks. We usually measure them in months because that's just the complexity of the work that we're doing. It's usually, a few months.
Okay.
So, but it really depends on the complexity of the project. I mean, there are certain projects initiatives that could be multi-year, right? And we have to
Oh,
break it
okay.
down into, okay, the first phase, we have to break it down to phases where the first phase, we have to build this infrastructure, right? We might need to build this infrastructure this quarter, and building the infrastructure itself could be just 3 months.
Uh,
Then the next 3 months, it's okay, we have to get these teams to use their infrastructure. That could be another 3 to 6 months. Then after that, we have to do this phase. That could be a a larger initiative, or it could just be a project where, okay, the overall it's going to be 2.5 months. It's going to be 3 months, 3 weeks to plan, and then about 2 months to execute on it, and you figure out the timeline based off of the tech lead or whoever the lead is doing the research to figure out what the solution is, and based off the solution and having an understanding of, okay, as an engineer, certain tasks take a certain amount of time. You kind of get an estimate of like, okay, based off the tech spec, there's going to be X number of tasks. And usually it takes engineers this many days to do one task. So based off that, it's going to be 2 months, 3 months,
uh,
4 weeks. And that's kind of how you measure the length of a project. And it's even doing that is like a skill, it's an art. It's an art to do that. You're not always right. You're not always gonna be right. Even as a tech lead, I get things wrong. It's really hard to estimate things because requirements change. Things you think that are straightforward might not be straightforward. And then to be honest, there's imposter syndrome as well. You think like, man, is my estimate, fast enough? Is another engineer could do it faster than me? You still have those that imposter syndrome that you feel when you're earlier in your career that doesn't go away. You just kind of get used to it. And so that's kind of how, you go about, estimating the length of a project. And it really depends on a lot of different factors. And what a tech spec includes is think about it as the blueprint for your entire solution. So if you're building, I think of software as building a house. So if you're building a house, you might have a general idea of what the house is going to look like, but you need to make sure that the plumbing is done a certain way. You need to know what the layout of the square footage of each of the rooms is gonna be. You have to know what are the framing you're going to use, what material you're going to use for the framing, how you're going to insulate the roof, how you're going to do all these things, what material you're going to use for the roof. You have to make sure you have your permits. And so you'll create a blueprint for the entire spec of the house. And so a tech spec is essentially that for software.
Oh,
And what that'll look like is, let's say you want to build a dashboard for your team, your company. Maybe this dashboard monitors, I don't know, can monitor anything. Monitors users, tracks users, how frequently users use different features of your app. A tech spec says, okay, what is the design for this dashboard? And a designer is going to create that. An engineer is not going to create that. A designer is. So the
I
design is literally just like what it looks like
mm-hmm.
and when you click on things, what the interaction is supposed to look like. So you take that and you're like, okay, what technologies do we use at this company to build different parts of the solution? So maybe on the front end, we use React at the company. So okay, we're going to be building out the different parts of this dashboard with React. You know that, okay, okay, we have to make sure things are tested. So based off the designs, you kind of get a sense of, okay, there are various levels of tests you need to write. And you get a sense of that as just being a software engineer in the industry. You know that, okay, for small pieces of this, we usually add these tests. So we have to make sure this functionality is tested. Or we'll look at the main functionality, the most important functionality of the dashboard and say, hey, we make sure we have tests for that. So that's all outlined in the tech spec in detail. Like you test this feature, these features need to be tested. These parts of the dashboard need to be built this way. We need to use React. We need to use this library that the company uses for this specific type of functionality. We don't own the page that the dashboard lives on. Another team owns it. So now we have to add work to reach out to that other team, ask them, hey, can you give us advice on how to update your own code? What tools should we use that you guys use to build this out? You literally write down all the tools.
Oh,
You
wow.
bas- you write down all the tools that we have that have to be used. You take in that feedback from the other team. If they own that page. If they don't, you don't have to worry about that. But you're writing down all the tools that you use. You're literally writing down how you're gonna use the tools to build each piece. And you break the whole thing down into pieces. So you think of it as like a step by step. Okay, first we're gonna do this. We're gonna do it this way. Then we're gonna do this. We're gonna do it this way in very as much detail as you can. So it's not like general, like, oh, build a dashboard.
Okay.
Make sure there's data there. No, it's we're going to create a container for the dashboard. That's
Mm.
one task. We're going to use these tools to do it, and we're going to do it this way, and it's going to live in this part of the code. That's one task. Next task. For getting the data, we know that the data that we need to display in the dashboard comes from this API that this backend team owns. And they tell us that we need to use these API endpoints to get this information. And these API endpoints, when they send us the data, it's going to be in this format. So we know that this is the shape of the data. And then we're going to take that, we're going to build a React component that takes that data and creates and makes the right visualization for the dashboard that we expect. And we're going to do it this way. And this is essentially how we're gonna do it. That could be four tasks. So you're going to that detail, and the tech spec is all of essentially all of that. And the reason why you go into that much detail is because you want to make sure that, especially if you're working with multiple people and you're dividing and conquering, you want to make sure that everyone who's doing this knows exactly what needs to be done so that you guys don't walk on each other's toes. This person's have this idea, that person's have an idea, and then you have different ideas and you clash, which if you're a student, I'm sure a lot of the students kind of have that experience, right? You think it should be done this way, the other person should think it should be done this way, and then you kind of clash throughout the project until you kind of get it done. That cannot happen in the professional setting. There has to be a solution that you all agree on, and that's outlined in the tech spec. And then you just focus on executing. Now I'm just building. I don't have to worry about the blueprint anymore. This is it. We're doing it, and we're good to go. And so that's essentially what the tech spec does. It also outlines what are the risks, right? What are the potential delays? How do we roll this out? So when we're done developing this, how do we release to the customers? How long is it going to take to release to customers? How are we going to measure success? How are we going to monitor the feature afterwards? You write down all those things. And so everyone is on the same page all the engineers are on the same page with the solution. Your leadership who are not technical are on the same page with how, when they're done with this, how do we know that this is successful? Oh, they're going to set up monitoring dashboards so that we could look at to be like, oh, it, it's successful because I don't know, 50% of our users are using this. And I know because the engineers set this thing up, right? Also, in the future, after you build this feature, if any other team looks at what you built and they want to update it, or let's say all of your engineers, you built this 2 years ago, all the original engineers who built it are not at the company anymore, right? You
Right.
you have new team members. There's a whole new design for the dashboard. Those team members look at the tech spec to see how it was built, so they know how to update it because they have a blueprint of how it was built. If they have
Ah,
that blueprint, then these engineers are going to spend weeks going through the code, going through everything, asking questions, trying to figure out how did they build this thing, why they use this, why they do it this way. The tech spec tells you, so it's easy for you to just be like, okay, they made these decisions, they did it this way, so now I know how to update it. So it's a blueprint for the team, it's a blueprint for leadership, but it's also a blueprint for any future person that wants to understand how this is built or how we should change it. So that's pretty much what a tech spec
and so
includes.
the tech spec evolves, as you were talking about it, including how decisions were made. So you're starting with the original tech spec, but then you're including, information on how decisions were made or different issues were resolved with the tech spec. Is that a fair analysis that
Yeah.
it?
And
Okay.
usually what you just said in terms of adding decisions that were made, you'll do that as a team after, say, the tech lead creates the tech spec. That's like a draft. Then you meet with the team, get all the feedback. Maybe certain engineers like, hey, that's not going to work. That's not going to be good. You're forgetting this. We add that all in. And then once it's agreed on, we try not to change it as much. Now, in the real world, requirements change all the time. We might
Right.
be working on something and we realize, wow, this is harder than I thought, or this is easier than I thought. We don't actually have to do 10 of these 10 of our tasks. We can
Right.
do this in one line. So so when these bigger changes happen, which usually aren't as frequent as the initial tech spec, you might go back and update the tech spec, a few times when these bigger things happen. Uh, People try to update after the fact, but in reality, once the tech spec's agreed on, people rarely go back and update it. I try to do that because I love being transparent, but
Right.
but yeah, check spec is kind of just like the North Star technical solution and all the gotchas and essentially everything in detail of how this is going to be executed.
Right. And I see there are some questions, but I have one more, and then I'm going to turn to Tamika to give us the order in which to for these questions. Then I'll come back with more questions. So I have more questions, but I do see a number of questions coming up. And that is, so with your group, and that is the group global, and do you have to travel to see the group, or is everything done, virtually with groups that may be in different countries? And do you have to travel with Atlassian being Australian company? Do you travel there as well?
So our company is completely 100% remote, and my team specifically, most of the engineers, everyone is in the US, but I'm in Texas. There's a couple people in Austin, some people in New York. There's some people in Virginia. There's some people in Washington. There are a bunch of people in California. And so we're across different time zones, but the same region. But what's interesting about Atlassian is, like you mentioned, it's an Australian-based company. And so what that means is that we have different products at the company, so Jira, Confluence, Trello, etc. And so depending on the product, you might have most teams that work on that product might be in a certain region of the world. So most people that work on Confluence are in the United States. Most
Mhm.
people that work in Jira are either in Australia or in India. And
Okay.
so when you're working across those time zones, we don't really travel that much. Like we
Okay.
don't but we have ways in which we collaborate together across time zones to make sure we're still in sync across all these teams, across all these time zones. So for example, every team has their own Slack channel and they have someone called Disturbed. And that person is essentially for like 2 weeks, it's just one person on the team. They don't have any work to do except answer questions when other teams come to your team Slack channel and be like, "Hey, Disturbed, what does this mean? What is this?" And they're asking you things about your team. That one person during company hours is answering every question for anybody who asks a question about your team. And every single team has that. So if you and which is convenient because you're going to get a response within a day, guaranteed. Even though it's like you're in the United States, you need help, you need urgent help from someone from Australia. If we didn't have that system, you could be waiting for days, weeks. They're focused on their work and it's a different time zone. So you're going to lose, you know, during the day in the United States is night for Australian people and India people. But with this system, you always have someone answer your question all the time, always have someone to review your work. Most situations, the max you'll have to wait is 2 days. And so
Okay.
that's really how we communicate. And then in terms of meeting in person, we do what's called on-site. So it's not really off-site, it's on-site. So they'll fly and they'll fly a group of teams to one of the offices to have a week of just activities, bonding, also planning for the quarter. And so we do.
Mhm.
When I first got here, we did that every quarter, so 4 times a year. And now we do it twice a year. So that's when we kind of meet each other for bonding and things like that to be connected. But other than that, we just do everything completely remotely. The Disturb thing that I mentioned really helps make sure everything's in sync. It can be in sync as well.
So do you, and I love this concept of disturb, okay? Because we have Slack channels, but it's kind of random who answers. So with this disturbed, is it rotating between different people, part of a project, as to who has that task of answering the questions in the Slack channel, or?
Yeah, exactly. You rotate with everyone on your team. And so we actually have a schedule where after one person does it for a week, then it's the next person. You could actually see your schedule months in advance and it just rotates through everyone on the team. And it's handled through this software called Ops Genie that we use. And so you're essentially on the roster for the schedule. And when it's your time to be disturbed, you'll get notified a week in advance. And then the day before, they'll let you know. And yeah, it's pretty much automated. So you're just on a schedule and we rotate.
Okay, oh, good. Okay, and then let me just, Tamika, if you want to let us know about the questions and if someone should unmute and ask their question.
Here we have some questions in the chat. We have Oniche wondering, what do you like most about being a tech lead? We also have a question from Rocio wanting to know, as a tech lead, how did you develop your intuition? How did you figure out what to look for? Are there books that you read on design, system design? and are some of your observations from what you've experienced, from seeing patterns. And finally, we have a question from Mike wondering, can you speak to the transition from engineer to tech lead and what types of acquired skills are needed for that type of leadership?
Okay, thank
A lot of
you.
great, a lot of great questions.
Right?
I'll try to be succinct because I tend to be long-winded. But what I like most about being a tech lead, I think I like having, so I'm someone who's very much long-term planner. I like being strategic. And in order to do that when you're building software is you have to build software that's flexible, that is um, follows best practices and is consistent. And everyone has to kind of try to do it that way. And the reason for that is that you want to every individual engineer to easily know when they go into the code base how to update it, where to make changes, things like that. But if everyone's writing code based off their own personal style, it makes it that takes it you're essentially adding time to everyone else's work because now I have to go into the code and like, man, this code is 10 people updated it. They're all doing it in different style. And now it takes me so long to understand that work. And so what does that relate to long-term thinking? And so as a tech lead, I essentially have visibility on like what all of our engineers are doing. And I'm also working with leadership to plan quarters in advance. And so I'm looking at what is happening now. And I'm also thinking, okay, how can we build software to set ourselves up for things that I know are coming down the line that a team doesn't even know about? And I like being able to have that visibility because it allows me to think strategically on how we need to write our software. I like having those conversations with leadership of like, hey, I think this feature that we're planning would be great. Why don't we add this? Why don't we add that? Um, and I like doing that. And then also I love the mentorship side of things. I love helping people. It's also why I'm, part of Command It. I love doing these things. And so, when I'm giving people feedback and about the things that I just discussed, I'm also want them to grow into better engineers. I want to see them. I want to get to the point where the feedback that I give them, they can give that feedback to me, And when I see that, I'm like, okay, that person is ready. I don't have to worry about them as much. Like they got it. They have the confidence to give me consistent feedback. And I love that. I love that. I love seeing people grow. And actually, I would say that last part is probably the most rewarding part of being a tech lead is just helping people and watching their growth.
Right. And I think it was Roscoe who was next. And Roscoe, uh, oh, sorry, Rocio Roman, do you want to unmute and show your video and ask your question?
Oh yeah, I can ask my question.
Okay.
Hello. Yeah, so I was just wondering, I think with the level of intuition, uh, looking out for certain, I guess, future roadblocks when designing a system from scratch. Like, was it just a cumulative, experiential like knowledge, or do you just supplement that knowledge by reading books? Like, how do you go about that?
Yeah, that's a great question. And I think every experienced engineer is going to give you something different. Um, but a lot of it was earlier in my career, just being obsessed with best practices. How do you build good software based off the technologies that I typically use? Because I worked on the front end for the most of my career. So what does it mean to write good, clean code? How do you what are the JavaScript concepts that you need to understand so you could write better, more efficient code? Same thing with React, testing, things like that. So getting kind of that foundational knowledge. And obviously there's also books that you could read about, system design, refactoring. But when it comes to that intuition, that's like pretty much your experience, like actually building projects. It's almost purely that. So when you're used to building projects, like think of it as you're kind of what's the word I'm looking for? You're kind of like battle tested. So if you're going in, you know that, oh man, every time you build a project, the last 10% of the project takes the longest because there's always like You gotta write you always leave the testing for the end. There's always bugs that you never figure out, but you don't know that until you've built projects over and over and over and over again for years. And not just build projects, but like planned projects and executed projects for years. Then you kind of just know, okay, that's gonna happen. And also when you're working with leadership, another thing you realize like okay you get to know okay well, your product manager what product managers kind of like to care about when you're executing a project. You kind of get to realize oh yeah, a lot of leadership, they don't really care about your timelines. They might not care about certain difficulties. They want to get things done during the project. After they might not finish the requirements, so you have to kind of keep your eye on them because they might not finish the requirements. You think they're done, and then all of a sudden, when you're in the middle of developing, they're like, "Oh yeah, can you do this too? Can you do that too?" And now it's like we can't do the original timeline if you keep adding more stuff to it, you know?
Right.
So you after doing projects a bunch, you know that they're gonna do that. And so
Hmm.
a lot of it is just doing the pro building out software for years in your career, and then you just know that these things always end up happening, always. And that's really how you build the intuition, and then all of your knowledge of things that you've learned, whether it be just like through, reading, watching videos, just teaching yourself, school, all of those things help give you the core skills to adapt to the that intuition that you adapt to that intuition that you build up and still make sure you're able to work well.
Wow.
Yeah, that answered my question. I was also thinking about real quick, just another question. Um, how habits like affect when you're like early in your career as an engineer, like the kind of team that you're in, right? Did you find like that mentorship early in your career? Was that critical, do you think, for your building you up to like a tech lead, finding the right, like I don't know, to kind of being around the right kind of people that are, I don't know, like super knowledgeable and are open about mentoring. You think that's also critical?
I think that is important, but also people have different personalities. I'm an introvert, so I was never good at finding mentors. People that mentor me. Also very
Mhm.
observant. I would just
Mhm.
be a sponge to anyone that around me. I would pay attention to, when people write code that's well, or people just operate in
Mhm.
a professional setting, in a team setting well. What are the things that they're doing well? There's always people on your team that always have a good reputation. Why? Paying
Mhm.
attention to that. What are things that they do? And a lot of what they do is nothing to even do with their coding. It's just like their personality, their leadership qualities, their transparency, things like that. I remember when I was working at MongoDB, I had a coworker. He wasn't even a tech lead. He We were essentially on the same level. And I've never heard anyone communicate as good as him to this day. And I just paid attention to the things that he would do is you'll ask a question and he'll be like, so what you're asking me is this, right? Right?
Mhm.
To validate that now we're on the same page with what the problem is. Okay, based off that, I think the solution should be this. And I paid attention to that. I'm like, man, everyone loves working with this guy. I love working with him because I learned so
Mhm.
much and I feel so heard and seen working with him because he always makes sure to understand what you're talking about. Whereas there's a lot of engineers that just like they'll try to solve your problem, but they don't take the time to understand what your problem is. They'll just like, hey, just do this, just do this, do this. And you're like, wait, you don't understand the problem yet. So just paying attention to the things that people do well, but also people things that people don't do well. When you're working in certain code bases, you see certain things happening all the time and you realize, man, it makes my life harder, other people's lives harder when things are done this way. Or you see certain people being stubborn and seeing that actually have real life roadblocks to the rest of the team. You're paying attention to that. And so in the absence of a mentor, I was just very observant with what people did well and not do well. And
Mhm.
I use that as kind of like meant to mentor myself as
Right.
went through my career and develop those intuitions like you mentioned and experience.
Okay.
Yeah,
Yeah.
I feel like I can do that. I think anybody on this call can also do that. Like, be super observant. That's a really good quality to have.
And then
Yeah, thank
also
you.
Yeah, also real quick, conferences, definitely go to conferences, hackathons, watch
Mm.
talk. Obviously, always educate yourself personally. If you are able to have a mentor, that is amazing. They could give you feedback on different ideas. Maybe they could even give you feedback on your code, give you feedback on interviewing. That's all of that that helps. And so, even though whether you're an introvert or not, you could find places to find people that could teach you things. And the tech industry is pretty welcoming. There's always people doing tech talks. There's always people doing, free meetups. That stuff is, plentiful. And so take advantage of those things as well.
Okay, thank you. Thank you, Rocio. And we have Mike T, I think, has a question. Did you did you want to unmute, or shall I or Tamika ask the question? She mentioned it earlier, but
Can you speak to the transition from engineer to tech lead and acquired skills needed for tech leadership and the challenges you faced? Great question. I try to answer it succinctly, but there's a lot that goes into it. So first, I would say there's the technical skills and soft skills aspect of being a tech lead. The technical skills is just getting good at, the technologies that you use. So if you're a front end engineer, getting good at all things related to front end, not just, oh, I know how to use these tools, but I know how they work underneath the hood. I know best practices. I understand how the web works. I understand performance, accessibility. I understand testing. I understand, all these different things, different strategies to implement each one of those things well, why you would do those things. Same thing on the back end. Back end, it's like, how do I make things more efficient? How do I make queries more efficient? How do I build, a system? How do I, scale my database? How should I use should I use microservices architecture? Should I use a different type of architecture, monolithic architecture, things like that, like building out that. And maybe you use primarily Python. So getting very intimate knowledge of Python or Java or whatever the technology you mainly use as you're doing the back end. Um, I would say the same thing for full stack, but there's no real full stack engineers in my opinion. It's usually either a back end engineer that's very good at back end, that doesn't mind working on the front end, or a very good front engineer that doesn't mind working on the back end. You can't really be specialized in both, because each one of them is such vast disciplines. And then there's other things like DevOps engineers, but that's just getting a deep understanding of technologies you use, and also getting a deep understanding of how to build software, not just like small projects, but like larger and larger scale projects, right? So applying your knowledge to build larger and larger scale things and getting used to doing that. And that's like part of that is not just side projects, but taking on more responsibility at your company, putting yourself in positions where if you're able to do tasks really well, asking your managers for opportunities to lead projects. And after leading projects a few times, then you kind of get to, and you're able to practice applying your knowledge in larger and larger ways. And so that's, the technical side, just having that deeper technical knowledge of your side of software engineering. The soft skill side is the side that people don't really talk about, that really sets people apart when it comes to tech, like tech lead, any kind of leadership. That is when I say mentorship, what I mean. So there's let me list things: mentorship, having good people skills, being able to communicate to non-technical stakeholders, being able to manage stakeholders' expectations, taking responsibility for not only your project, but your entire team's code base, like your entire team, taking responsibility for your team, for the products that you own, um, and helping people consistently, not even like sometimes, just like that is part of what you do every day. And so, what do all these things mean? So, speaking to stakeholder management, learning how to talk to a product manager who might not know code, speaking to them in layman's terms, speaking to a designer in layman's terms. They don't need to know about, oh yeah, I can't do that because in React, When you're hydrating a component like that, that would actually, cause this whole thing to re-rent. They don't care about that. They don't know what you're talking about. So speak to them in layman's terms, right? Understanding the things that they care about. A designer cares about making sure that, knowing what a designer cares about, which is different than what a product manager cares about. Knowing what knowing what they care about when they're looking at a project, understanding that they have managers and bosses that are pressuring them. So understanding that they have pressure, and so making their lives easier, and knowing that and not taking things personally. Not taking it was a huge thing, not taking things personally, being an ally to them, being like, how can I help you? Help me help you. And having that mentality, right? Managing them, understanding their needs, and being able to give it to them. Even if you can't do something for them, be like, hey, we can't do it, but we could do this. We could get you part of the way there. So always just being trying to help with those people as much as possible, pushing back when they have unrealistic expectations, which is also part of managing. Just don't say yes to everything, but using your experience and your intuition to be like, hey, that's not going to work. That's going to derail us. So, but this is going to work, or these things are going to work. So doing that, whether it be your product manager, designer, senior engineering manager, director, VP, doesn't matter. You have to be comfortable doing that with all of those people. And if you're in a startup, probably the CEO too. So you have to be able to talk to all these different people. And usually it's not even technical when you're discussing things with them. So doing that, when it comes to mentorship, it's consistently being a resource for people on the team, answering questions. So when you're on a team, you look at the tech leads or the senior people, their names are always popping up on Slack. Why? Because they're constantly answering people's questions. They're constantly making themselves available every day to help people. And when you're a junior, that's really hard to do because you have to constantly stop your work, help someone for an hour, go back to start your work, going back, and you're like constantly going and pulling different directions. So it's very hard to do. But after you get used to, as you go through your career, you're going to get comfortable doing it more and more. By the time you're like a senior engineer for a few years, a tech lead, it becomes second nature, like to switch like that on the drop of a dime. Time, which also, time management, things like that. So being a resource to people. Also, what I said about being a tech lead, code reviews, always doing code reviews every
Yeah.
day. No, it doesn't even matter if it's your project or not. Anyone on your team puts out code, you're reviewing it. Obviously you can't do everything, but doing code reviews every day, like it's like second nature. It's very hard to get into that habit too. It's a habit you have to develop, but as a tech lead, like something you're doing because you're responsible for the code hygiene of the team and upholding best practices and making your team better. You're a multiplier, right? If you have a team full of junior engineers, by the time they're done working with you for like a year or so, they've leveled up. You want them to level up. You want to be able to level up people. So doing that consistently. The other thing is like knowing how to de-risk projects, having that intuition of how to execute a project, making sure it doesn't go off the rails, so that you're consistently delivering projects as close to the original timeline as possible. So knowing the gotchas, knowing that, oh, these things could happen if I'm not paying attention to it. Oh, this engineer is taking a long time to do something. I have to pay attention to them. I don't have tunnel vision working on my own thing. I'm watching what they're doing and being like, oh, the third engineer on this 5-man team is taking a while to do this, and they're going to delay this person in 2 weeks. So paying attention to all of that. So managing the the health of a project. And so you're constantly, that is like not even really technical. It's just having awareness and being able to context switch all the time. And the thing I would say is when you're an engineer, you could just focus on your own work. You could just focus on, this is my project. These are things that I'm working on. You're also helping people. You're also doing code reviews, right? And great engineers constantly help people doing code reviews, answering questions. Great engineers do that. When you're a tech lead, it's not like that is absolutely what you need to do. Whereas great engineers, some senior engineers don't do it as much as others, right? But if you're a tech lead, you have to do it. That is just absolutely what you need to be doing. And so there's a lot of just the soft skills aspect of it, that has nothing to do, like when I listed all those things, that has nothing to do with coding. That has nothing to do with how smart you are. That has nothing to do if you mastered every leak code in the book. Doesn't matter. It doesn't matter. Has nothing to do with system design. Just everything to do with people management, understanding people, helping people, being a resource to people, and getting into those habits and still executing on your work and your team's work and that constant concept switching. And so I think that when you're thinking of your awareness of your team, your projects, when you're a junior, your awareness and scope is individual tasks. When you're mid-level, it's a group of tasks. When you're a senior, it might be a whole project, right? That's your scope. When you're a tech lead, your scope is multiple projects, potentially like things beyond your department. When you're like a tech lead and above, so your scope and visibility that you have to keep track of just grows. So that's long-winded way to answer the question of like the difference between when you're transitioning from an engineer to a tech lead.
Okay, thank you. And one quick follow-up question, and then we'll go to, I think, is it Opie Lua? So if you can be ready to ask your question. And that is, you talked about the soft skills. How does that come from experience and observing in terms of gaining those soft skills? Or would you recommend a communication class? Just want to get your thoughts about those soft skills.
For me, those soft skills came naturally to me, and I think it's because I had an unconventional path into the tech industry. I did not major in computer science.
Mhm.
Took one comp sci class my senior year, and that's where I fell in love with software engineering. And I essentially taught myself and did a boot camp to get myself into the industry. Whereas before, when I was at Amherst, I started off being a math major. Then I switched to being an Asian language and civilizations major to focus with a focus on Japan and Japanese. Um, and at Amherst, there's an open curriculum, so there's no required courses. You could take any course you want. I took courses on sociology, psychology, economics. I took a class on like Chinese philosophy. I took a class on, slavery and the American imagination. I take a class on statistics, all these different types of disciplines, and it really helped me, you know, learn how to be critically think with the various topics even beyond things that I don't understand, things that I do understand, constantly, just reassess my assumptions and also to be able to communicate about these various different types of topics. And that gave me foundational confidence to be like, okay, I could talk about anything with anyone because I've had to do that in, while I was an undergrad. And so I probably have a lot better of those soft skills than most engineers that are around me because I didn't have come from that traditional background. I think the one thing that if I would say to students who are still in college that are comp sci students, I think one mistake that people that STEM students make is that they're just focusing on STEM classes and that's it. That is it. The technical skills and that's it. But if you're going to be a leader in this industry in your career, especially when you're thinking about AI and how it's transforming the way we work, where it's just like, technically you could use less and less of your brain. What becomes important? Things that have nothing to do with your technical ability. And so being able to critically think and think outside the box. Part of that is take classes that have nothing to do with with software engineering. Take classes that are just might be random that might interest you. Maybe there's a political science class that seems very interesting. Take that. Take a class that is very foreign to you. Take a writing class. Actually, please take a writing intensive
Yeah.
class more than once because documentation is super important in software engineering, in the software engineering field. When you build something, you have to document it. A tech spec is all writing. Document your software because software that's not documented is like a nightmare for the team, nightmare for entire companies. And so you're learning to use your brain in so many different ways, and it makes you a better engineer too. It all transfers back, right? When I was doing interviews in the beginning, I was literally telling interviewers, being like, "Hey, me learning how to speak Japanese, become fluent Japanese, is like the same skills that I would use to learn a new coding language. so that I could learn it quickly on the at the company and do essentially any project. And I was able to articulate all the similarities between learning Python, learning JavaScript to learning Japanese, and how technical actually learning Japanese is. You know, if I just worked in comps, I couldn't make those kind of connections. And the brain power needed to make that kind of connection, the same brain power that you use to talk to an engineer about something technical, and then 5 minutes later communicate that same thing in layman's terms to a product manager that doesn't know anything about code. And so really just you know, diversify your coursework beyond just software engineering. And even after college, take an interest in things that have nothing to do with software engineering. It'll make your career, it'll enrich your career, enrich your work, enrich your thinking, and just enrich your life in general. So that's what I would say in terms of the soft skills. It just came naturally to me because I didn't come from a conventional environment.
Understand. Thank you. And that's great advice, especially about the writing, other classes outside of STEM. But I want to spend the last few minutes on the topic of AI. And you mentioned this briefly, but want to spend a little time with AI. And that is, so we're hearing a lot now, especially with generative AI and the use of large language models. And so one question that comes up is, sometimes you hear people even saying that, in the near future, a lot of the software is going to be written by AI. But my question is, how are you using AI in terms of software development? And what do you see in terms of future uses, especially in terms of the generative AI? So I'll turn it back to you.
That's a great question. I don't use AI as much, but beyond just using like GitHub Copilot, which is just like automatically, giving you code suggestions based off of your code base, asking it to, do things like maybe, create a test suite for this file that you just updated, things like that. That's the full extent of me work doing it at my job. But at my company, we're using AI to kind of to really enhance the experience of a lot of our products. And if you think about it, Jira, Confluence, a company will put all of their requirements, all of their essentially proprietary information about their products in Jira and Confluence. And so if we're able to build AI tools that are fully optimized using that data and fully optimized for these individual companies, then we're able to give them hyper specific,
Right.
solutions really tailored to their experience, not something very general, but it's like, you know, we have so for example, one of the earliest features that we use using one of the feature that our team built recently that uses AI is in a Confluence document, you might highlight some text and you want to create a Jira ticket out of that text or multiple Jira tickets from that text in say a chart in a Confluence page. You could highlight that text and be like, hey, create multiple issues, and then a thing will pop up and it'll auto populate all the metadata for a Jira ticket based off the hypertext that you highlighted using, using what's it called? The LLMs that some of our core AI teams have been made available to engineers. And so for us, that's at least what I've seen in my company, that's how people are using it. But I think more broadly, it's really just making people more efficient at different levels. Um, and I don't think, when it comes to the question that probably everyone is asking is like, oh, is AI going to replace our jobs? I think there are a lot of barriers to that because AI still is not able to solve very complex problems in a company. Like you could, build a project from scratch with AI and like get most of the way there. If you're a junior engineer, you don't actually know the thing is whether what's right or wrong, and maybe if you have issue, if it ends up being wrong, you don't know how to fix it, and you could kind of get stuck there. But if you're an experienced engineer, you know how to fix it and tweak it enough to like get it working. So you can build something from scratch. But think about companies that have been around for 20 years. All of that code was not built by AI, and if you're going to build features, you need AI to understand all of that to build the feature. But also, AI is not going to know what feature you need to build. You still have to talk to customers. You have to get feedback from customers, and you could get data based off customer usage for your feature and use LLMs to like suggest features based off user, I'm just making this up. You could um use AI to LLMs to probably just like pipe in that data, and then they could suggest features that could help customers, and maybe those things would be great. But sometimes some features might completely new that kind of have nothing to do with user usage, right? And they're features that are kind of net new that customers don't know that they want or they need. And so that's still going to require some human, interaction. I think the thing that you're going to see is that, well, you're already seeing right now is that, teams are able to be efficient. Essentially, you could make an engineer team smaller and get the same amount done with AI. And as more and more engineers adopt AI into their workflows, that's going to become more and more true. I think when it comes to building companies, you're going to see people able to build companies faster and scale companies faster because they essentially don't have to really hire an engineer. But when it comes to like replacing our jobs, there are so many companies that exist that dominate everything that we do. Most of the code is not built in AI, and AI still struggles with very complex problems, despite what people like Sam Altman will tell you, like what people would tell you. Like they these things can't solve these problems effectively. And even if they come with solutions, you still need someone experienced to be able to check the work, because it's not always right. Now, I'm saying that now, right now in April 2025, but these things are evolving and growing really quickly. And just like the early stage of the internet, I don't think we could truly predict what's going to happen or how it's going to impact our lives. Technology is moving quicker than we could adapt to it. And based off that, we don't know how us as human beings are going to respond to it, whether it be a consumer, whether it be an employee, whether it be a founder, a CEO, an owner. And when you think of the early stages of the internet in the 2000s, it's like, people just fooling around doing a bunch of random stuff, like people on MySpace just goofing around, playing games, you know, and just like finding random communities. Who would have thought that the internet would be dominated by social media apps that essentially just mine our attention and create these hyper focused silos, individual silos that's just our own bubbles? Who would have thought that would happen based off the early stage of the internet? And that things like that, make it easy for us to understand, be hyper aware of every little like minor conflict that's going on anywhere in the world, right? Who would have thought that this would cause, you know, depression issues with like young children, even adults, right? Who No one would have thought that. No one's getting depressed on MySpace in 2004, 2005. So no, you would have never thought that. And those technologies were created pretty quickly. So now these things are updating so quickly. We can't fully predict it, no matter what anyone says. But based off what I'm seeing, it can make engineers more efficient. Which also means that teams can be smaller. And then on the flip side, when you're building something from the ground up, you can build something from the ground up faster. But you need to be able to I think if it were to fully replace our jobs, you need to be able to update existing code that are like decades old, build new features on top of that, and all that automated with AI, and then also AI needing to be able to understand what the user wants in features and then build that. That's when you could like essentially get rid of all this. So
So
all
I
of it be automated.
know and we'll all be around. So
Yeah.
definitely, Jensen. So this was fantastic to learn what you do as a tech lead, also tech specs, learning also your experiences and the value of both hard skills and soft skills. So I want to take this opportunity to say thank you very much for participating in our webinar and for us gaining insights into your journey, your career journey to a tech lead at Atlassian. So with that, just to say thank you. And I know there are a number of thank yous in the chat. So we appreciate your time. And thank you everyone for participating. This was great.
Absolutely. Thank you so much, Valerie, Shannon, Tamika. This was amazing. Really impressed with everyone's questions, by the way. Great questions. Loved answering these questions and appreciate everyone joining and, hearing me blabber for an hour.
Oh, hearing your insights. Thanks so much, Jensen.
Thank you.
All right, everyone, have a great day.
Bye.